Hey guys, it's Miss Johnson and I'm here to bring you our notes for Unit 1 Learning Target 4. Today we're talking about slope-intercept form. So the slope formula, up at the top of your notes sheet, if you haven't gotten your notes sheet out already, please go ahead and grab your white notes sheet for Unit 1 Learning Target 4. Grab something to write with and grab your calculator because you'll probably want your calculator today. Up at the top of your notes sheet, you have a box for slope formula. So your slope variable, I'm going to write this off to the side, is m, which is kind of interesting because m doesn't really stand for slope, but that's what our slope variable is. So m is equal to the change in y over change in x, meaning y2 minus y1 over x2 minus x1. This is what we call the change in y over the change in x. Okay, all it means is change in y, change in y over change in x. All it means is how far has y moved? How far did the y value move? And the way we find out the distance something moved is to subtract it. So we take the difference in the two y values on the top and the difference in the two x values on the bottom. Okay, so you saw in that slope formula that there was a y2 minus y1 on the top and an x2 minus x1 on the bottom. So I want to show you where those values come from. I've got 2 points here that I'm going to calculate the slope from, and I'm going to call my points x1 and y1 and x2 and y2, because in an ordered pair, the x value comes first and the y value comes second. X value comes first, y value comes second. So when you take those 2 points, now you want to plug them into that slope formula. So once again, I'll show you that slope formula. So my slope is y2 minus y1 over x2 minus x1. So in this case, I would plug in y2, which is 16, minus y1, which is 8. And I would divide that by x2, which is 9, over x1, which is 2. If you look, an ordered pair is stacked on top of itself. So the y value from the first ordered pair is right there. The x value from the first ordered pair is right underneath it. So those two, the 2 and the 8, make an ordered pair, and the 16 and the 9 make an ordered pair. So that's how they ended up going together. We want to make sure that we keep those two together. Whatever was in an ordered pair should be one right over the other. All right, so then if I take care of that, 16 minus 8 is 8, and 9 minus 2 is 7. So my slope is 8 over 7. Okay, 8 over 7 is an improper fraction, but that's okay. We're going to leave it that way. And the other thing about 8 over 7 is that it doesn't have any like terms. You can't reduce it, okay? It's not like 8 over 4 where they can be divided. Okay, so I'm just going to leave it like that. That's my slope. All right, let's try it again. So in number 2, our 2 points are, here's my x1, here's my y1, here's my x2, here's my y2. So I've got 9, negative 16, and negative 7, 15. When I plug them into the slope formula, it looks like this. My y2 comes first, negative 15 minus negative 16. We'll talk about that in a second, but you got a double negative there. Then on the bottom, negative 7 minus 19. Okay, now that numerator, negative 15 minus a negative 16. When you have minus a negative in the middle like that together, these two become a positive. Because you're taking subtraction, which goes one direction, but you're subtracting a negative, which then turns it around to go the other direction. So that ends up being addition. So when I take negative 15 plus 16, and you can do this on your calculator, negative 15 plus 16, I get 1. Now in the denominator, negative 7 minus 19, that's not a double negative, that is subtraction. So negative 7 minus 19 gives me negative 26. So my slope, my slope here, where's my undo? I know there is one, there it is. Negative 26. My slope here ends up being negative 1 over 26. Now, when your slope is negative, when you have a negative in either position, so like in this one I had a negative on the bottom, it really just makes the whole thing negative, and that puts it out front of the fraction. If I had two negatives, if I had a negative on the top and the bottom, those two negatives would cancel each other out and make it a positive. But this is a negative slope, so there you have it. All right, let's do number 3. I have x1, y1. That's a comma in the middle there. Sorry if my handwriting makes it kind of hard to tell. x2, y2. So my slope looks like negative 19 minus negative 19 divided by negative 2 minus 1. All right, so negative 19 minus negative 19. There's that double negative again, so that becomes plus a positive. Negative 19 minus, or plus 19 gives me 0. And then negative 2 minus 1 gives me negative 3. So I end up with a slope of 0 divided by negative 3. If you typed that into your calculator, you're just going to get a slope of 0. All that means here is that there is no change in that line. You know, this is slope of a line. So this is a line that was negative 15 over here at positive 1, and then negative 19 over there at positive 1, and then negative 19 down there at negative 2. This would be like my x, this would be my x of positive 1, and this would be my x of negative 2. The line hasn't changed. It didn't go up and it didn't go down, okay? So that's why I have a slope of 0, or in other words, we call that no slope. You'll hear it referred to as no slope. There's no slope because there's no change. It's not going up and it's not going down. So let's try number 4. I have x1, y1. I have x2, y2. And then my slope looks like this. Negative 4 minus 7 over negative 6 minus negative 4. So that becomes plus a positive. Negative 6 plus 4 gives me a negative 2. Negative 4 minus 7 gives me negative 11. There's that double negative there. A negative divided by a negative is actually a positive. So this is a positive 11 halves, or a positive 11 over 2. And I can't reduce those at all, so I'm going to leave them as they are. All right, so now let's talk about slope-intercept form. Slope-intercept form of an equation is y equals mx plus b. M is that slope variable that we've been talking about. B is the y-intercept, okay? And so this is an equation where on a coordinate plane, okay, let's say you have a line that looks like this. Okay, this point right here is the B, that's your y-intercept. And then you find the slope by picking 2 points. I didn't do that very well. Picking 2 points and calculating the change in y over the change in x to get the slope. That little triangle means change in y over change in x. So that's what this equation is for. And this is quite possibly the most common form of an equation. It's the form that we use for a vast majority of what we do in algebra, but we use it to graph equations primarily. So now it says, let's write the equation of the line in slope-intercept form given the point and the slope. So just a refresher, here's slope-intercept form, y equals mx plus b. So your slope and your x go together. These two things are going to stay variables. Y and x are variables. Your slope goes in with the variable, and we have to find the b. this is going to be our question because we don't know what that is. So if we don't know what that is and we're finding the b, let's take this point that we know. We have an x and a y. Okay, there's my x, there's my y, and I'm going to plug those two things in. So I've got 2 equals, and then -6 times 9 plus b. And the question is, what is b? So I have to solve this, simplify this, so that I can get that b value. 2 equals, -6 times 9 is -54 plus b. Then I can add that 54 to both sides, because that makes that go away. And I get 56 is equal to b. So now that I have my b value, now I'm going to go ahead and plug that in and rewrite my equation, keeping y and x as variables. So if I write this as an equation for any point, it looks like y equals my slope, which is -6, times x, plus my b value, which is 56. That is the equation of this line. Okay, let's try it again in number 6. So again, here's slope-intercept form, y equals mx plus b. Now right now, I have an m, and I have an x, and I have a y. I don't know the b, and that's what I have to figure out. So I'm going to take my -3, that's the y value, and plug it in over here. Then I have 2 times -2, which is the x value, plus the b, which I'm trying to find out. So that's my goal. What's the b? All right, so -3 is equal to 2 times -2, which is -4, plus b. And then I need to get rid of that -4. So I'm going to add 4 to both sides, because that makes those go away and leaves me with b. -3 plus 4 is +1. So 1 is my b value. Now if I rewrite that whole equation, I've got a b value of 1 and an m of 2. So y equals 2x plus 1. That's my slope-intercept form equation. All right, in number 7. So again, here's my slope-intercept form. That's the standard form of the equation. I have the m, which is good, and I have an x and a y. So let's plug those in. -5 is equal to my slope of -2/3 times the x value of 3. And then plus that b that I'm trying to determine. Okay, so I need to take -2/3 times 3. You can do this on your calculator. On your calculator, you would open a parenthesis, type negative, type a 2, type divided by, type a 3, close your parenthesis, then hit your multiplication key, and then you can hit 3 and see what it gives you. This would be the keystrokes of what you would do on your calculator. Otherwise, if you think about it logically, this 3 is 3 over 1, and I'm taking a 3 and dividing it by 3, and those two things are really going to cancel out. I have -2 over 1, which is just -2. So you probably got -2 if you did it on your calculator, which is great. I'm going to add 2 to both sides. -5 plus 2 is -3, so that's my b value. And now I'm going to rewrite the whole equation. Y equals -2/3 times x minus 3. I did a -3 there because my b value was negative. All right, number 8. Y equals mx plus b is my form of my equation. You don't have to write that every single time. I'm just doing it so we have a reference. Here is the m, here's the x, here's the y. I don't know b, so let's plug in what we know. I've got 4 equals 1/2. I'm going to put that in parentheses just because it's a fraction, times -2. I'll put that in parentheses because it's a negative, plus b. And again, b is our question. That's what we're looking for first. I'm going to multiply these two together. Half of -2. That's what you're finding there. 1/2 times -2, which is really just half of -2. So I have 4 equals -1 plus b. add the 1 to both sides. So that makes those two go away. My b value is going to be 5. And then I end up with an equation. Once I rewrite it, so there's my b, there's my m. Y equals 1/2 x plus 5. All right. I'm going to go through these ones. You have m equals 4. There's an x. There's a y. If I plug that in, it would look like 7 equals 4 times 6 plus b. Sometimes my b's and my 6's look similar, so I'll try to make it clear. 4 times 6 is 24, so 7 is equal to 24 plus b. And then I'm going to subtract the 24 from both sides, making that go away. 7 minus 24, I'm going to type that into my calculator to check myself, but I should get a negative 16 there. Minus 24, negative 17, negative 17. See, that's why I checked myself. So negative 17 is equal to my b value. There's my b, there's my m, here's my equation. Y equals 4x minus 17. So the whole point of us writing these out as an equation is because now I can take any x value I want and plug it in there and get the y. So this makes it a standard equation for me to be able to evaluate any point on the line that I want to. All right, number 10, here's m, here's my x, here's my y. So I have 2 is equal to negative 1/2 times negative 4 plus b. And again, you can type that into your calculator if you want. Make sure you put parentheses around the two of them, and this is being multiplied. First thing I'm going to do this by hand. I'm not going to type it in my calculator, and I'm going to talk you through how I see it. So the first thing I'm going to recognize is the fact that a negative times a negative gives me a positive. So I know I'm going to have a positive value. Then I'm going to treat this as a 4 over 1. 1 times 4, if I multiply these two fractions together, I have 1 times 4 on the top, which is 4, and 2 times 1 on the bottom, which is 2. 4 divided by 2 is simply 2. Okay, then subtract the 2, and I end up with 0 equaling b. Now there's two different ways that you could write this. You could write this as y, so 0 is your b value, negative 1/2 is your slope. So y equals negative 1/2 x plus 0. That's a perfectly fine way to write that. There's nothing wrong with it. However, you don't have to write the 1/2. So you could also write this as y equals negative 1, I'm sorry, you don't have to write the 0. That's what I meant to say, not the 1/2. You have to write the 1/2, that's the slope. But you don't have to write the plus 0. So you could just write this as negative 1/2 times x. Because we all know that adding 0 doesn't change our answer. It doesn't make anything different, so we don't need to write that. Okay, so we're actually going to move on to number 11, and I'm going to tell you why. We don't need to do another one of these types again. We've done quite a few already, so we're not going to do that one. But one thing I want you to fix on your instructions of your notes, this is not supposed to say point slope form. This is supposed to say slope intercept. Okay, so change that on your notes sheet, and then we'll try number 11. So write the equation of the line in slope intercept form given the 2 points. So now in this one, we don't have the m yet. All we have is 2 points. So we have to start by finding the slope. This is our x1, this is our y1, this is our x2, this is our y2. All right, so I'm going to find my slope first. So I'm going to take my change in y, 4 minus negative 12, over my change in x, 8 minus 4. So that means I have 4 plus 12, which is 16, and 8 minus 4, which is 4. 16 divided by 4 is 4. So there's my slope. Slope is 4. Now you just pick one of the points. I'm going to pick this point because I like working with positive numbers, and I think it makes things a little bit easier. So I'm going to pick one of the points, and then I need that slope, and I'm going to plug it into my slope-intercept form. So there's my slope-intercept form. Mine would look like 4 equals 4 from the slope times the 8 plus the b that I'm trying to find. Remember, b is that question. What are we looking for? So 4 is equal to 32 plus b. Subtract the 32. 4 minus 32 is negative 28 is equal to b. So if I rewrite that equation, it looks like there's my b, there's my slope. Two things that I found. I have y equals 4x minus 28. That's the equation of my line. Let's try number 13. So again, change your directions. Get rid of this. It's not point-slope form that we're looking at. It is slope-intercept form. Okay, so in number 13, here's my x1, y1, x2, y2. So then I have a slope. I have to find slope first. So m is going to equal negative 3 minus 1 over 0 minus 2. Negative 3 minus 1 is negative 4. 0 minus 2 is negative 2. And I get negative divided by negative, which is positive, 4 divided by 2, which is 2. So my slope here is 2. Now you can pick either point. It does not matter which point you pick. I'm going to go ahead and pick this point, and I'm going to show you what happens when I have the 0 there. So if I plug that into my slope-intercept form, I have y, I have the y value. I have negative 3 is equal to 2 times 0 plus b. So there's my y, there's my m, and there's my x. Okay, so see what happens here. 2 times 0 is simply 0. I end up with negative 3 equals 0 plus b, which is really just negative 3 equals b. I don't need to go through the hassle of subtracting 0 because 0 doesn't carry any weight. So it's not going to change my negative 3 over there. And I want you to recognize something in your point. I had a 0 for the x. The negative 3 ended up being my b. Whenever you have 0 for your x value, that y value is your y-intercept. So that's a good thing. That makes our life easier. So now when I plug this back in, here's my b value. I found the m of 2. I have y equals 2x minus 3. All right, last one. Maybe you'll start to recognize something in this question. So I have 0, negative 1. There's my x1, y1. Here's my x2 and y2. So m is 3 minus negative 1 over 2 minus 0. Change in y over change in x. The 3 minus negative 1 is plus a positive. That's 4. 2 minus 0 is 2. So I end up again with a slope of 2. Okay, so again, if I look at that point, I've got an x value of 0 and then y of negative 1. That means that b is equal to negative 1. And I don't even need to go through all of this. Because I see that my x value is 0, that y value is my y-intercept. Because I know that I'm going to multiply by 0, which is going to be 0, which doesn't change anything. So that negative 1 is my y-intercept, and my equation looks like this. Y equals 2x minus 1. All right, that is the end of our notes for today. Thanks for listening, and go ahead and work on your practice assignment and let me know if you have any questions. I'll catch you next time.